All right, we're going to take a look at section 4.3, which is dividing polynomials. And there's two ways for us to divide polynomials. The first one is treating it like a long division problem. And the second here is using what we call synthetic division. Both work out. Synthetic division might be a little bit easier once you get the hang of it because of the organization and not have to deal with so many of the variables that get in the way. Two main differences between or the main differences between polynomial long division and synthetic division. I'd say one thing to remember in polynomial long division is that terms, you're going to subtract terms. In synthetic division, you are going to be adding terms. And I'll explain that when we take a look at our problems. We'll talk about how to write remainders when we do go on to the working on some of the problems here. And let's just go ahead and go to number 1. Okay, it says let's divide using long division. So remember, we have x squared plus 6x plus 12 divided by x minus 3. And when we have it set up like this, remember this first piece goes on the inside, the x minus 3 goes on the outside. So I got x minus 3 on the out, and I'll go ahead and put x squared plus 6x plus 12. And so some key things here. All right, we have to figure out first off, we start with the x minus 3, and I got to figure out how do I go from x to x squared? How is that going to be possible? Well, let's go ahead and put an x right here. Because if I take x and I multiply it by x, that'll get me my x squared. And then we have right here x times negative 3, that's going to be negative 3x. And so I can go ahead and put that right underneath the 6x because they share the same term or have the same variable. So remember, what I said happens here is this. In normal division, we end up subtracting, right? So that's why I said we're going to subtract the terms. So x squared minus x squared is 0. We got 6x minus negative 3x. So hopefully we get that right there, and that's 9x plus 12. We'll bring the 12 down. And then, just like before in regular synthetic or regular division, we're going to go ahead and repeat the same process. I want to take right here with the x minus 3, or how many times can x go into 9x? Well, that'll be 9. So I'm going to go ahead and put right here plus 9. And then I want to take this 9, multiply it by x. I get 9x, and then 9 times negative 3 is negative 27. And so once again, we're going to be subtracting right here. 9x minus 9x is 0. 12 minus negative 27. That becomes right here, we get 39. And we end up with the remainder. Okay, so we can't move on any further. We came to the end of the line, that's your remainder. So how do I write the remainder? Since this is a positive 39, up here I'm going to put plus, and I'm going to put 39 over x minus 3, what we divided by. And there you go. We have now finished this problem and divided. So all of these parts right here, you're going to need to make sure you know in order to do long division. Let's go ahead and move on. Let's take a look at number 2. So we have x squared minus 16. We'll go ahead and divide that by x to the third minus 4x squared. There are some little problems that we're going to encounter. So let's see what those are as we go along. So for me to go to x squared to x to the third, I'm going to have to multiply right here by x. Because x squared times x to the first gets me x to the third. Okay, so great. And then what happens here is this. I've got x times negative 16. And that's going to get me negative 16x. The thing here is this. I cannot put that underneath the 4x, negative 4x squared. I want to have to put it right here to the side and put negative 16x. Because I can't subtract these two right here. They don't have the same terms. So the thing here is this. We have to add some spacers or something for it to combine with. And what I wanted to go ahead and do is put right here plus 0x. Because that really won't change things other than you're adding to 0 or subtracting, right? So remember, we are subtracting when it comes to this step. And so let's go back right here. This is supposed to be not x squared, but x to the third. So this becomes 0. I've got negative 4x squared minus, and then we could go ahead and put like 0x squared. And so that'll remain negative 4x squared. And then we have 0x minus negative 16, or 0 minus negative 16, which is going to get us plus 16x. And then we repeat the process. So now we have x squared, and I've got negative 4x squared. Okay. Well, this is where you got to also be very careful. How am I going to be able to get rid of these two? Well, remember, we are subtracting, so I have to have negative 4x minus a negative number in order for us to get rid of this. So what I'm going to go ahead and do right here is I want to put minus 4. Because if I multiply this right here, that'll get me negative 4x squared. Negative 4 times negative 16, that gets us right here a positive, what is that, 64? And then we're going to go ahead and have to put plus 0 and add that to our problem right here. All right, so we've got quite a few things going on. We're going to go ahead once again. We're going to subtract right here. So negative 4x squared minus negative 4x squared, that gets us 0. We've got 16x minus 0x, so that's going to get us 16x. And then we have 0 minus 64, and that'll be negative 64 right here. All right. So can I take now, we're going to continue the process. Can I go from x squared to 16x? Is there something that you can multiply so that instead of being x squared or 6, we have to change, it'll be able to combine with the 16x. And we can't. There's nothing more. So that means that this right here becomes my remainder. Because there's nothing I can multiply by x squared to get x, or 16x. So then this becomes plus, we have 16x minus 64 all over x squared minus 16. All right. Looks like there's more that you could simplify, but this right here is pretty much the gist of the problem, and we'll leave it at that. If you look at the denominator, you have a difference of 2 squares. At the numerator, looks like you could factor out a 2. So there is more that you could do there, but like I said, we'll leave it at that for now. Let's go ahead and move on. I think now you have an idea of long division. So next up, let's try synthetic division. And remember, we said in synthetic division, we're going to be adding the terms together. Now, the setup is quite different. What I'm going to look at right here is this x minus 2, or what the polynomial is going to be divided by. What I'm going to have to do first right here is I want to go ahead and draw a little corner. and I want to drop in the number 2. So the number that you put in here will be the opposite of the number you see inside of the binomial. Okay, so that is the first and most important thing right here. So if you pop in a -2, it's not going to work out. All right, so the next step, what I'm going to do now is I'm going to go ahead and I'm going to write the coefficients of each term. Okay, so the coefficient for x squared is 1. The coefficient for x, -10, and then we have our constant, which is 2. So there's a specific method in what you will do in order to now figure out what the numbers will be for when we divide it. So what do we do? Okay, I want to go ahead, I want to drop down the 1, and we have 1 right here. The next step is this. I'm going to take this 1, multiply it by 2, and put that number right there. Now remember, when it comes to synthetic division, we are adding. Okay, so I'll put a plus sign right here for now. And so now we have -10 plus 2, and we have -8. After that, okay, then we have -8 times 2, -16. Okay, I took this number right here, multiplied it by what's in the corner, and then out came -16. And then we'll go ahead and add things up, and we will have right here -14. So this right here, if there is a number left over, and that is your remainder. Now what we have to do is write our polynomial together. Remember, if I took x squared and I divided it by x, then I'll be left with x. So if I take x squared and divide it by x minus 2, it will reduce the exponent or the power. So what happens here is this. I'm going to take this coefficient, and instead of this being x squared, this will represent x. So it'll be 1x. I don't have to write the 1, but it's there. And then this will be the constant. So we're going to descend, so x minus 8, and then we have right here our remainder. It's going to be -14 over the x minus 2. And there you have it, synthetic division. Okay. Let's try it again. Let's take a look at number 6. So I'm going to go look right here at the x plus 2 at our binomial. And up in the corner, we're going to go ahead and put -2. Put the opposite of what's in there. And then we're going to look at the coefficients of what's being divided. X to the third, that coefficient is 1. For x squared, the coefficient is 4. X, coefficient is 6, and then we have 4 right there. And I'll go ahead and draw my line, and there we go. Okay. First off, we bring down the 1. Okay, automatic comes down. We take this 1, we multiply it by -2, and that gets us -2 in here. Don't forget, synthetic division, we are adding. So 4 plus -2 is 2. Then I'll take this 2, multiply it by -2. Put that answer right here, -4. And now we have 6 plus -4, which happens to be 2 again. Then we take this 2, we multiply it by -2, and we get -4. And when I add 4 plus -4, I end up with 0. And that's a good thing, because that means we don't have any remainders. It works out perfectly. So let's once again think about this. Our polynomial started with x to the third. We're dividing it by x. So that means the highest power will now only be x squared. And that's what I'm going to attach to this 1x squared, or just x squared. Then we have the 2. It's going to be 2x. It's going to descend, and then plus 2 right there for the constant. And there you go. X squared plus 2x minus 2 is what you end up with. Let's go next to number 7. So hopefully up in this corner, you know what to put down. It's going to have to be a -3. So number 7 ends up having some of the same problems that we had in number 2. Okay, you're going to encounter some of the same situations. Because right here, if I look at my coefficients, all right, I start with 2x to the third. So I'm going to go ahead and put a 2 right here. However, the next term should be x to the second, and there is no x to the second. So what I'm going to have to do is put a spacer down like I did in number 2, and this 0 will represent 0x squared. And then let's go ahead, we're going to have to do it one more time. Why? Because this next 0 represents 0x. And then we have minus 54. Okay. So in order for this to work out, you have to put these space holders in order for you to correctly use synthetic division right here. So think, all right, I've got to have things going in descending order. And if I don't, then you're going to end up with certain problems, and you're just not going to end up with the right answer. So if there's little gaps where you're saying, hey, there should be like, how am I supposed to match up the x squared when I'm left with the x? Then you need a placeholder like in number 2. And the same is going to have to happen right here in number 7. So let's go ahead now. Let's solve the problem out. 2 comes down. I take this 2 multiplied by -3, and that number goes underneath the 0. Once again, we are adding. So 0 plus -6 is -6. -6 times -3, positive 18. 0 plus 18, 18. Then I have 18 times -3, and that right there is -54. When I add these up, I've got myself -108, which isn't really a problem. It just tells us that we have a remainder. So let's now put our polynomial together. Remember, our highest power was x to the third. It got divided by x, so my highest power now is x squared. And we'll go ahead and put right here 2x squared. We're going to descend, so now we have minus 6x, and then we have plus 18. And then we've got to go ahead and include our remainder. We got -108 divided by, right here, x plus 3. And now we've used synthetic division right there. Okay. Let's go ahead and go down right here to number 13. All right, so it says we're going to use synthetic division to evaluate the function. Okay, so it's kind of an easy little short method of trying to evaluate without having to plug everything in. I mean, you could simply use a calculator, but they're saying there is other methods, right? You gotta love Common Core. So the first thing right here is this. It tells us that x equals 2. So because it's not a binomial, we're not going to take the opposite. I'm going to go ahead and just put down right here 2. And then let's go ahead right here. I've got -3. I'm going to go ahead and put down the coefficients 4, -17, and -6. All right. So we go ahead and let's repeat our process. And what they're saying here is this. All right, let's go ahead. I'll bring this down. We got -3. -3 times 2. -6. 4 plus. Right, don't forget we're adding 4 plus -6, -2. -2 times 2, -4. Add this up, we end up with -21. -21 times 2, we get -42. And what I end up with right here is -48, my remainder. What this remainder actually is the answer. If you were to plug in 2 into the function, you would end up with -48, is what they're saying. How will I write my answer? Well, when I plug in -2 for x, we have f of 2 is equal to -48. And there you go. One last one, number 14. So we'll start right here with -1, okay? Because this is not a binomial, it's what it is. And then let's put our coefficients down. -1 is the first one. What should come next? If you said 0, you are correct. Because remember, this is supposed to represent x to the third. And then we go to 1 to represent our x squared. And then we have to put down 0 again for 0x, and then 4. So even on these problems right here, you do have to have placeholders in order to solve them out. And so let's go ahead. I'll drop down the -1 times -1 is 1. We'll go ahead right here, adds up to 1. All right, so we have 1 times -1 is -1. So 1 plus -1 is 0. 0 times -1 is 0. 0 plus 0 is 0. And then we're left with 0 times -1 is 0. And we're left with 4 right here. So what that's telling me is that when you plug in -1 into the equation, you will be left with 4. And now you know how to use synthetic division to evaluate a function. And also divide and use long division. That right there is section 4.3.